Good. You should be also seeing me as well. Okay. Okay. Good. Good. Thank you so much. Um, so I've shared my screen. You should be able to see me as well and see the slides. Thank you so much. Good. So, hello everyone and welcome to Kaizen Academy's 12th live webinar. Yes, this is our 12th webinar. And today we are going to discuss scientific problem solving using the A3 methodology. My name is Ahmed Radwan, and I'll be your host for this session. So whether you're joining us from a factory floor, an office, or halfway across the world, we are thrilled to have you here. And before we dive into our topic today, let's get to know each other. So where are you joining us from today? So drop your location in the chat. I'm joining today from Melbourne, Australia. Okay, Mexico, Jordan, USA, Kentucky, Arizona, USA, UK, Serbia, USA, Germany, Paris, Tennessee, okay, Florida, good, fantastic. Spain, Saudi, Canada, South Africa, Poland, Northern Ireland, Kenya, Greece, USA, Houston, Argentina. Okay, that's fantastic. So it looks like we have a truly global group today, um, which is really great and exciting. Um, so um, let's get started with our topic today. So here is what we will be covering today. So we will start with what makes problem solving scientific. Then we will dive into A3 thinking and the PDCA cycle and the 7 basic quality tools. And also we will be having a quick test of your knowledge during the webinar, and you will have the chance to win 1 month access to the our problem solving course, and also a certificate of distinction in problem solving. So this will be provided to the uh, 3 of you according to your performance in our quiz today that we will be presenting at the end of the webinar. And also we'll be having a Q&A session, and also, as some of you might have received, you also have we will be also presenting today an exciting opportunity for an exclusive offer to our certification program, which is the Lean Practitioner Certification and Coaching Program. So stick around. Scientific problem solving is about identifying the problems that you're trying to solve and its context. And it incorporates identifying the current state and target state condition, analyzing the problems or the opportunities based on facts, not impressions, and also building solutions based on solid grounds of facts and proper analysis. Then we test those solutions and we check if they produce the required target condition, like any proper scientist, step by step, in a methodological way, in a structured way, in order to reach a conclusion. And it's not about filling out a piece of paper or using the tools that we're familiar with, but rather a scientific approach to step by step in order to reach the correct countermeasure. And let me ask you this question. Have you ever encountered a situation where you later realized that you were solving the problem in an ad hoc manner, in a random manner, just chasing for a solution without really understanding the current condition or the target condition? What is the problem that you're trying to solve? Have you encountered this previously in your professional or even personal experience? A yes or no is sufficient in the chat. So have you experienced this before? Nice. We as human beings, we tend to jump into conclusions. We like solutions. We don't like analysis that much, but we like solutions. This is why we try to jump into conclusions, and we try to, yeah, find the next right solution rather than understanding or analyzing properly. Um, so A3 thinking. So A3 thinking was developed by Toyota, and it's a mindset and a tool that helps you document problems and solutions on a single sheet of paper of what is known as the A3 size. So the A3 size is just double A4 papers next to each other, about 30 by 40 centimeters. And it's about clarity, collaboration, and continuous improvement. And integrating the A3 into team activities helps companies stop avoiding problems and view them as opportunities for learning and improvement. And the A3 thinking promotes a scientific approach, again, that encourages individuals to observe, present data, identify proper solutions, and adjust based on results, like a proper scientist. And it serves as both a problem-solving tool and a structured process for developing skilled problem solvers. And uh, and as we mentioned here, a scientific method that includes observations, use of data, proposing countermeasures, checking and adjusting. Um, so uh, if you look at these steps, so observing, use of data, proposing countermeasures, checking and adjusting, what does that remind you of? Think of an improvement approach that is comprised of 4 letters. What is the improvement approach that incorporates those 5 letters? Yes, it's PDCA. And the make is, I would say, similar approach to it in the Six Sigma world. That's right. So the PDCA cycle, or Plan, Do, Check, Act, is a cornerstone of A3 thinking. It's like the scientific method for problem solving. And you plan for your hypothesis, you test it, you evaluate the results, and then you adjust. And this iterative cycle ensures that learning never stops. Okay, so PDCA consists of 4 stages. First, plan. So you identify problems, you set process goals, you outline necessary changes, and you think of this as forming a hypothesis. Okay, and then do is basically you implement the proposed changes or the new process. And this is like conducting an experiment. And then you check, which is evaluating the results, and you reflect on what was learned. And then finally, act, which is integrating the learnings into new processes. You standardize the changes, and then you repeat, and you focus on adjust and standardize. Good. So that an A3 typically includes the problem background. So it includes the problem background, and it includes the current condition. It includes countermeasures, analysis, post counter yeah, post countermeasures analysis, proposed countermeasures, planning, and then the follow up actions. So background, current condition, root cause analysis, countermeasures, and follow-up actions. And this ensures that every angle of the problem solving is covered. And this precise format and wording, they are not set in stones, they are flexible. And most organizations tweak the design to fit their exclusive or unique requirements. And it's not the format of the report that matters, but the underlying thinking that leads the participants through a cycle of PDCA, or Plan, Do, Check, Act. And the 7 tools can help in identifying the 7 quality tools that we're going to discuss today. They can help in identifying the current condition, goals, and targets, analysis, and many other aspects of the A3. We will discuss later today which tool can be used in which part. And we will be providing, as promised during the previous communications, we are going to provide you with this template in the communication following the webinar. So this is an example of an A3. So again, starting with the background, current condition, analysis, goals, countermeasures, future state map, the countermeasures plan, and also the follow-up finally. And again, as you could see, it's kind of different from what we saw in the previous slide in terms of the format. So the format is not fixed in stone. Again, here is another one. But as you learn new things, if you're new to the tool, you try to use the template as it stands. You try to follow it, and then once you really feel that you are familiar with the components and what is the logical flow, then you can adjust it to as per your unique situation. And A3 thinking is more than merely a tool, as we highlighted in the beginning, as it represents a mindset that encourages ongoing learning and development, and it fosters collaboration among team members, it enhances communication across different levels, and it drives continuous improvement within an organization. So by adopting A3 thinking, individuals and teams can systematically identify problems, analyze root causes, and develop actionable solutions. And this approach not only enhances efficiency, but also creates a culture of transparency, collective problem solving, which leads to a better outcome and more engaged workforce. Something that any organization should be striving for. So now we are going to, so we talked about the A3 methodology, what is the science behind it, and then now we are going to talk about some tools that can be really helpful while you're going through while you're using the A3 methodology. So what are the 7 basic quality tools? So the Japanese professor Kaoru Ishikawa, who also developed one of these tools, is well known for developing one of these tools, the fishbone diagram that we use today. So he played a key role in the development of the 7 quality tools and the concepts of the quality circle during the quality movement in Japan in the 1960s. And because quality tools were at that time were often perceived to be complicated, it's not easy for day-to-day workers, the day-to-day workers to use them. He tried to introduce a set of tools in a simplified way so that everyone will have access to these tools and use them on a daily basis. And then at that time he introduced these tools in his book Guide to Quality Control. So the basic quality tools include histogram, cause and effect diagram, check sheets, Pareto diagram, graphs, control charts, and scatter diagrams. Okay. And each tool has its own unique purpose, and you should not push the tools into the problem that you're trying to solve, but pull the tools as you need them. So like the comprehensive use or the use of all the tools is not the objective, but rather to use the relevant tools to the problem on hand. And we are going to discuss each of those tools, but we will be focusing a little bit more on the histogram and Pareto diagram. I can see some questions related to the presentation. Yeah, I'll be sharing it after our after the webinar. So after the webinar, I'll be sharing the um, the slides, the templates, and also the recording of this session. So let's start with the histogram. So histograms are perfect for visualizing data distributions, and they help identifying patterns and variations in processes. For instance, you can use a histogram to assess to evaluate the product weights in manufacturing, and and in order to know what is our current performance or actual performance, or if there are any variations within the product weight, for example. And using the histogram, it's easy to find the shape, the central value, and the manner of dispersion in your product weight. And consistent quality depends on understanding um, uh, these insights in your process. So the central value, the mean, and um, the distribution of your data, right? So for example, if you say I sell my appliances and I sell my dishwasher, and the average of life, the target average of life is 3 years, but some of your customers are experiencing 1 year life and others are experiencing 10 years life. This would indicate to you that you're not consistent with your quality. So this kind of tool will be helping you to evaluate and understand your actual process performance. And to develop a histogram, you will need to pass through 4 stages. So for example, we have here some data that reports the thickness of a product. So you need to calculate the range. You need to identify the number of classes. You need to calculate the classes and frequency in each class, and then you draw the histogram. Okay. So for example, the range is the difference between the minimum and maximum. In our case, the difference between the maximum value and the minimum value is 0.38. Okay. And here, if you follow these steps, you will be able to uh, see something like this. So this is a representation of the same data on a histogram, and it shows you that like you have the variation from 3.3 until 3.68. The most occurring values are between 3.43 and 3.51. So I think you will agree with me that having a histogram, you are in a better position to understand the performance of your products or processes, right? And let me ask you this question. Have you ever used a histogram in your work? And in what context? Like how was it useful for your specific situation? Let me know your answer in the chat. Good, good, nice. Thank you for sharing these examples. And in order to like once you draw the distribution, it's not just about drawing it, it's about interpreting it to understand what it really means. So there are many ways to read a histogram or interpret a histogram. So you can do that by reviewing the shape of the distribution. And for example, we have here, this is the, so we did a histogram, and now we can see that we put on it the lower specification limit and the upper specification limit, and we now know that yes, most of our performance is within the specification limit, but we have a high variation, um, or high dispersion, which indicates that the process requires further investigation in terms of its performance. Now, uh, let's go to the next tool, which is the which is the second in a row, which is the cause and effect diagram. So the cause and effect diagram is one of my favorite tools personally, and it's also known as the fishbone diagram or the Ishikawa diagram. And this tool helps you identify root causes by categorizing potential factors, and it's also very valuable for understanding why issues occur and where to focus your effort. So we had previously a webinar that is dedicated to this, the fishbone diagram, and also the 5 whys, and we're happy to share that with you if you're interested. So it's an educational tool for participation for all participants. It's a guide for discussion. It helps with identifying the root causes, the documentation of the identified causes, and it shows us how well the team understand the process, and it can be used for any problem. Is it quality problem, cost problem, delivery problem, safety issue, or morale? And then we have also the check sheet. So the check sheet is basically um, um, a manual way of recording your data, but at the same time interpreting it. So without a requirement for further calculations. So for example, if you don't have that much of, you know, um, digital tools at your hand, which is uh, very common, you can use this kind of templates in order to allow the operator or the production team to fill out wherever there are defects or there are any issues in a specific manner, and by doing that you will eventually build a histogram that you can understand automatically without further technological tools. Also, the Pareto diagram, it's a very uh, nice tool, which is it allows you to prioritize your problem solving activities. So on the left axis you would identify the number of defects or defectives, and on the right hand side you identify the percentage from 0 to 100, and then on the horizontal axis you identify the defective items, starting with the one that's most frequent, and building that will help you to say, for example, yeah, if I want to solve 50% of my problems, I should be like this. So if I want to fix 50% of my problems, I should be targeting those, connecting and calling. So if you fix those two, you will be able to fix 50% of your problems. Okay, and so the key benefits of this simple but effective tool is defining the priorities for improvement, building common understanding of priorities, and defining weight of causes, and tracking results. So how to make a Pareto diagram? You identify the classification, then you identify a time range, and then you sum up each classification for each classification, and then you calculate the percentage. You draw the bar chart from the highest to lowest total per classification, and then you draw the line chart showing the over the bar chart showing that the cumulative percentage, and then you try to use, then you use the cumulative percentage to target the what kind of problems should I target first. And again, for the previous tools and for this tool and the upcoming tools, uh, um, it it's useful, I would say, to understand the logic behind the calculations, and then you can use other tools like um, digital tools to calculate this, or templates, Excel templates, for example, which is handy to draw or to use these tools afterwards. And we provide these templates. So we provide an Excel template for each of these tools, including the A3 template in our courses as well. So again, the graphs, so there are different types of graphs that you can use for problem solving. So you have the line graphs, you have the bar charts, and then you have the circle graphs or the pie charts. And also you have the control charts. The control charts monitor process stability over time. They are essential for identifying variations and maintaining consistency. And by using those, you can ensure procedures remain within the acceptable limits. Finally, we have the scatter diagram, and with scatter diagram, if you have two kinds of data that you can index them and then plotting them on an ordinary graph. And from this chart, for example, we can know that as moisture context increases, the longevity increases as well. So they have a positive relationship between each other, right? And there are different ways of interpreting, or not different ways, there are like different trends or the pattern of data that you see after you draw the scatter diagram. So you can see here we have positive correlation, negative correlation, negative correlation but not that strong, positive correlation but not that strong, and here we have no correlation. So when you are using so we have all of these tools, and when you're trying to use the A3 methodology, here are the different tools that you can use at specific steps. So for example, in the analyze phase, you can use control charts, you can use the scatter diagram, you can use the cause and effect diagram or the fishbone diagram, and also the histogram. So this is a summary table that shows you which tools are commonly used in each stage of your A3. When you're trying to start your journey with A3, so don't stress about whether you're using a pen or a pencil or a computer program. Just begin wherever you feel more comfortable. Start the process and learn from your experiences. Develop a pilot, try to use it, and then for every A3 that you do, or a project or a problem-solving exercise, you need to have a sponsor for this project. Align the A3 with your organization objectives. Use Hoshin Canary if you're familiar with it, in order to derive A3s from the strategic objectives of the organization. Educate all stakeholders involved, so don't keep them in the shadows. Make sure that they understand what you're trying to do and what are the steps, what are the science behind it. And also standardize the A3 approach as a formal process for problem solving by integrating it within existing systems.